Okay, Chapter 7, Section 1, you guys are introduced to a new concept called slope fields, and it's a pretty easy concept. It kind of has a reputation of being easy points on the AP test. So start off with some quick notes. A differential equation gives the slope of the solution curve at a given point x comma y in its domain. This is also the slope of the tangent line to the solution curve at that point. Okay, so we'll quickly get through the notes so that we can look at an example or a couple examples. A slope field is a graphical solution to the differential equation. At each point x comma y, the slope field consists of a tiny tangent line with the slope given by the differential equation. Okay, so let's look at an example that explains everything that you just wrote down and some of the stuff that I emphasized by underlining. Go ahead and copy this example down. So for example, consider the differential equation dy over dx is equal to y. Some of the slopes given by the differential equation are as follows. Okay, so I start off by, I haven't given you the slopes yet, but go ahead and copy this table down, copy a graph next to it. Notice that I put points for each of the coordinates that I've labeled here. So go ahead and do that, and I'll show you how to proceed with this problem. Okay, so to start it off, I'm going to emphasize that, or I'm going to bring up that the differential equation dy over dx is equal to y, that's kind of like our key to obviously to fill in the column for dy over dx. So for the point negative 2, comma 2, notice that according to this differential equation dy over dx, our output is 2. Okay, so when x is negative 2 and y is equal to positive 2, dy over dx produces just 2. We plug in this 2 for y, and that's dy over dx is 2. Okay, if we move on to the next one, negative 2 comma 1, notice that when x is negative 2 and y is 1, we're going to plug in y is equal to 1 into my differential equation to produce 1. And then for 0, or I'm sorry, for the point negative 2 comma 0, we produce 0. So in other words, this differential equation dy over dx is equal to y. Notice that there is no x here, so the x values pretty much aren't affecting my output. It's really only the y value. So you can see that for the next one, we're just going to get negative 1, and then negative 2. Okay, we're really, our differential equation is just simply y. Now if this were like 2y, or 3y, or y squared, then, I mean, our answers wouldn't be just the y values, right? If it were, for example, y squared, my dy over dx would be 4 here. Okay? If it were 3y, my dy over dx would be 6. But it's just y, and there is no x, so it's just pretty much easy, just the y values. Okay. Then what you're going to do is you're going to pretty much represent each of these slopes on this coordinate, on your grid here. So I just pretty much emphasized the coordinates with points here. I just emphasized the points here, and now we're going to represent them with little tiny dashes. So I want to start with one that we're all familiar with. For example, the slope of 1. What does the slope of 1 look like? So I know I'm kind of starting at a random spot. Instead of starting at the top, I'm starting with 1, just because I think that we all know that the slope of 1, so for the point -2, 1, we can all agree that the slope of 1 is up 1 to the right 1, up 1 to the right 1. So it's just a nice horizontal, I'm sorry, I said horizontal, a nice diagonal line. Okay, so all you really have to do is draw a dash that represents a slope of 1 in this case. So remember that in the previous slide, I had you guys write down in the notes that it's tiny tangent lines. That's exactly what we're doing. Is we're doing tiny tangent lines to represent the slope here. Okay, so 2 is a little more steeper than 1. So a slope of 2 for the point -2, 2. -2, 2 is up here. Make sure that you make it a little steeper than the slope of 1. So make sure that you kind of make it steeper. This looks steeper than that. That's good. -2, 0, that's the point -2, 0. We have a slope of 0. So just draw your slope of 0. And so on. Now, -2, -1, for that point, we have a slope of -1. So it looks just like the one that you did for 1, but it's a slope of -1. So make sure that you make it look like a diagonal, a solid diagonal slope of -1, and then so on. So for -2, slope of -2 for the -2, 2 should be again significantly steeper, but in the negative direction. Alright, pause the video and let me have you guys grab this and then compare it with mine. So do that right now and pause the video. And you should have gone the same thing. The reason being is because our dy over dx is just y, so it all really relies on your y output. So if we're on the same y output, then it's going to be the exact same value. Okay, let's try that example. So they're asking us the same thing, same problem, just a new function, a new differential equation. So go ahead and copy this down. And notice that this time I made different points, obviously different ordered pairs here, and obviously producing different points here. There's no rule as to where on the grid you have to focus. You have to focus at the center, quadrant 1, quadrant 2. On the AP test, they will have points already laid out for you on the grid, so that you know where to place your tiny little slopes or your slope fields. Okay. So now we do have a differential equation that has both x's and y's, and we're actually adding. It's the sum of x and y. So for the first point, -1, 1, it's just -1 plus 1, which produces 0. So at -1, 1, let's go ahead and draw our little tiny dash of 0. 1, 1. So we got that. And actually, I want you guys to pause the video and complete this and then compare it with mine, so that you can kind of test yourself and see if you're getting the hang of this. So go ahead and do that now. And this is what I got. One of the main things that I want to bring out or point out is that you do want to use the slope of 1 as your guide when it comes to drawing the slope field or the tiny tangent line for a slope like -2, or let's say you would have gone 1/2, you want to guide yourself with the slope of 1. That's one recommendation that they gave me at the when I went to that AP training, or the AP conference. So the readers, or the AP graders, will be using that as a guide. They will grade your slope field based on how it's compared to the slope of 1 when you got a slope of -2, or a slope of +2, or and so on. You can get a slope of 1/2, or slope of +3 or -3. So long as you're making it relatively steeper, or you're using the slope of 1 or -1 as your guide, you should be good. Okay, and that pretty much does it for this video.